Good morning, people. Swapnil, good morning. Rishikesh, good morning. Mayuri, good morning. Kruti, good morning. Sanmit, good morning. Anjali, good morning. Ayush, good morning. Well, a few things to start with before we go into the actual aspects of the lecture. Prathamesh, good morning. That I've already announced it on the group as well, that very soon we would be shifting on to the Google platform. And as far as that platform is concerned, you would be requiring your credentials. So all those who have your credentials, it's fine. But those who don't have your Google credentials, you would have to see that you get it. And that is why I am delaying it, because once I shift there, it would be difficult for you all to log on if you don't have those credentials. Okay, that's the very purpose. I am not hurrying up the process of shifting to say the Google platform as such, but we are all ready with it. Okay, the classrooms are created, etc. Virtual classrooms are created, and it should be within some time that we should be shifting. It's only that I don't want students to be left out, and that is why the message yesterday. Those who still don't have the Google Classroom credentials through the college, official ones, as that is. I've already said yesterday as well that Professor Dahode is in charge of that, and he is going to create a Google form wherein those such students would have to post in their details, and once posted, it can be generated. Okay, and of course you could be joining the classrooms with using those credentials as such. Please remember that if you have not, if you are still in the process of registering the credentials, there are a few steps. First you get your credentials, then you register your credentials as such. Now while registering, you have to see that you have to come out of your own individual Google address or email ID to come out of that, and then you have to register your new credentials separately. Once you register, see that you change your ID, sorry, password as well, so that there are no problems, because eventually you will be writing your tests, you will be submitting your assignments on the Google Classroom. So if it is password protected, of course it is going to be better for you. So that is as far as the college news is concerned, and let us now move to where we had stopped yesterday. And as far as that was concerned, we were here, and you can see that as far as the waves, the different frequencies of the waves are concerned, how they cause. Of course, as far as surface waves are concerned, they are further divided into two, the Rayleigh waves and the love waves. Now, what I've done is I've put these together. In fact, the last three slides that we did, say this one, all of them, I've put together in this slide. Now you'll see that you have 1, 2, 3, 4, 5 here, and you have 1, 2, 3, 4, and 5 here. So you'll see that as far as the two types of surface waves are concerned, okay, they are considered to be destructive. You can see the destructive nature of these two. We'll concentrate on some of them one by one. So you'll see that as far as the lower two are concerned, the surface waves, you'll see that the particles actually tend to roll, and this rolling causes a higher amount of disintegration and destruction, I would rather say. And as far as these love waves are concerned, you'll see that they move like this. Okay, so either ways the destruction is higher. Then as far as the primary waves are concerned, we'll see that it is basically like a spring thing. Okay? The object goes into a springward motion, that's compression and relaxation, compression and relaxation. So that is the impact. And then you have the secondary waves, wherein the object moves up and down, up and down. Remember, love waves are side by side, and secondary waves are up and down as such. Primary waves, compression and relaxation, expansion and compression as such. So this is how it happens. Now, uh, this is something that we have done yesterday. That this is the focus. The point where the actual release of energy takes place is, of course, the focus, and the point exactly 90 degrees above the focus on the surface of the earth is going to be called as the epicenter as such. And then this is the shadow zone. Now, what exactly does that shadow zone mean? We are going to go into the details of that. Now, see that this part here, okay, this network here is basically surface waves. These are surface waves. These are secondary waves, and these are primary waves. Now, there is something that we needs to be understood as far as primary and secondary waves are concerned. I'll just put it up for our benefit. Okay, now remember that as far as primary waves are concerned, these are those waves. Now, primary and secondary, both of them together are called as body waves because they pass through all the layers of the interior of the earth. As far as surface waves are concerned, the Rayleigh waves and the love waves, you'll see that both of these, they just travel surface to surface. They don't go much deeper. Okay, they don't go enter into the mantle as such. So most of the destruction, and that is why one would say the most of the destruction happens on the surface because of the love and the Rayleigh waves as such. uh, as far as the primary waves are concerned, you can see here that they are traveling into the interior, and then when there is a change of medium, this is solid, the mantle is solid, and the uh, so to say the outer core is liquid. Okay, so there is some refraction. You must have studied the refraction on the prism based experience experiment that you did in your school days. Okay, you'll see, so there is going to be some refraction while it enters the solid liquid, then of course some more when it comes solid, and then when it comes out there is again some refraction. Now, interestingly, you'll see that when the primary waves enter, they refract outwards. And when they come out once again in the mantle, they refract inwards. Okay. Now, because of this, what happens is there is some area which does not experience these primary waves at all. Secondly, as far as the secondary waves are concerned, you'll see that they cannot pass through. Secondary waves cannot pass through liquids. Now, because they can't pass through liquids, once they enter into the outer core, they're lost forever. So it's only those which are at the base of the mantle and get reflected and come up till here, say 93 degrees from this 12 o'clock as such. Okay, it's only this area that you're going to have the secondary waves. Okay, and you'll see that you'll have primary waves here also, and you'll have primary waves now coming out of the outer core into this parts. Okay, leaving this area which tends to be empty of any type of waves. Secondary waves are not reaching here, primary waves get refracted. As a consequence, you'll see that you're going to have this area around 93 degrees to 142 degrees as such, which does not have any waves. So if for example an earthquake is happening at 0 degrees, however intense the earthquake may be, it will not be experienced. Mind my words. The earthquake will not be experienced between these degrees, 93 degrees. That is from this area on the surface all the way to 142, 143, as such. Such an area where you don't get an earthquake, okay, is called as a shadow zone. Remember, shadow zone for different earthquakes are going to be different, okay, on the earth, but geometrically it's going to be that area which is at 93 degrees, or rather from 93 degrees to 143, 42, 43 degrees from the epicenter. Let us be right in our terms. Okay, the epicenter as far as that earthquake is concerned. Now, uh, the actual P, say shadow zone, this is the P wave shadow zone, and this whole thing, okay, you remember the S waves came only up till here. Okay, only up till here. As a consequence, from this 93 to this degree here, this whole sector is a S wave shadow zone, and then you introduce the P wave shadow zone, which is going to be this one here. Okay, and you accumulate them. Okay, the effective shadow zone is going to be this, the area where you're not going to have any type of experiences of an earthquake with respect to, remember, this is dynamic, the shadow zone is dynamic. Every earthquake will have its own shadow zone. Okay, it's not that you have identified a particular area and that will not have. Some students ask me that question, sir, that means that there are going to be some areas on the earth which will not have earthquakes. No, that is not the case. Okay, shadow zones are in respect to, with respect to individual earthquakes occurring. From that point, 93 degrees onwards till 143 degrees, you are going to have a shadow zone which will not experience P waves and S waves, primary waves and secondary waves as such. So let us be very clear about seismic shadow zones. And once we are clear, we can move ahead. And let us see this graph as far as travel time curvature of seismic waves are concerned. Obviously, you'll see that the Rayleigh waves and the Love waves, okay, they tend to travel very, very fast. Okay, very fast. So you'll see that they'll travel to the center of the earth. Sorry, they'll travel a distance of 6,000 miles from the equator. Okay, remember these waves, and that is why you'll see that, because now your a scientific question would be, why is it that the Rayleigh waves and the Love waves are in a straight curve, or rather straight line, rather than the primary and the secondary waves are in curvature? The answer is going to be because these two are body waves and they pass through various layers. As a consequence, when they move from one layer to other, there is going to be a variation in the speed of travel and so on and so forth. And that is why the curve is gentle. Rayleigh waves, we know they pass only through the surface. Love waves only through the surface. As a consequence, you'll see that it's because they don't change, is it? The density doesn't change, so the curve is, rather the line is straight. Okay, and of course you'll see that they start traveling the fastest. They travel around 10,000 kilometers. Okay, here it is in miles, so around 10,000 kilometers just in 45 minutes. Okay, beyond that in 45 minutes as such. But you'll see, uh, sorry, let me just get myself right, that in fact you'll see that the secondary and primary waves tend to travel faster. um, Primary waves are the fastest. Sorry, extremely sorry. I just got carried away because of the curvature of these two. You'll see that 6,000 kilometers will be traveled, 10,000 kilometers will be traveled by the primary waves within the first 10 minutes. Okay, and the same distance, the secondary waves would take another 10 minutes, so around 21, 22 minutes. But it would take 40, 45 minutes for it to reach around 10,000 kilometers as such. So please let me correct myself, and you can correct your notes if you are taking down your notes as such. The slowest of them are the ground waves, that's the Rayleigh and the Love waves. Secondly, the curve is straight basically because they don't exchange layers, they don't travel through various layers as such, unlike secondary and primary. In fact, secondary will not travel through the outer core also. Okay, so that is another handicap as far as the secondary waves are concerned. But primary waves will start from one point and they can emerge on the other side of the earth also, and they are the fastest of the earth. And that is why you see that the first of the shocks normally experienced during an earthquake is tends to be of the primary wave. So it's very gentle and subtle, and then it starts getting rigorous. And by the time the Rayleigh waves are going to reach you, okay, and of course the if the earthquake is of a higher magnitude, it could be a very difficult thing if it's going to be of a higher magnitude as such. So please remember, primary waves start say move the fastest, secondary a bit slower, and the Rayleigh waves slowest. But the speed, uh, distance, okay, would be the curve, I would rather say, is the steepest as far as the ground waves are concerned. So let us move ahead. Now, what are the impacts of the earthquakes as such. Now remember that many a times we speak about these, but we need to classify these as two: the primary impacts, which means the immediate impacts, what happens immediately after the shaking of the ground, and then what are the secondary impacts. That means because of the primary impacts, it will lead to some other things, and so on and so forth. Now, the primary impacts, if we are to concentrate on, okay, it will lead to buildings and bridges collapsing, injury and deaths, rails, roadways, airports, and of course other ports being damaged. Electricity tends to get cut off. Uh, Gases and gas pipelines will break off, leak off, and so on and so forth. Telephone poles and cables will get destroyed. There's going to be a complete breakdown in communication. Underground water and sewage pipes would break, and that would lead to leaks and cutoffs also. And what would be the secondary impacts? They can trigger something which happens out of the first impact of the earthquake. They trigger landslides. I put up a photograph here about landslides. So this is a secondary impact. Okay, tsunami. Okay, and at times, if the landslide is in the coastal area, okay, so you'll see that, and of course, let me tell you that landslides to happen, they're called, funnily they are also called as landslides there, but you'll see that in the ocean relief also you're going to have landslides. These are, of course, may not be as fast, but then the volume would be larger, and you'll see that an earthquake plus landslide would lead to tsunami. A landslide plus tsunami will lead to more damage, isn't it? More injuries and more deaths, and so on and so forth. Leakages of gases was an immediate impact. This leakage of gas would lead to fires. Okay, secondary impact, first impact, houses will collapse. Because of these houses collapsing, you're going to have people going homeless. Okay, that's the secondary impact. Because I am homeless, I don't know where I'm going to reside in the evening. I could have psychological problems, because you'll see that as far as network, etc., is concerned, you can at least restore some amount of it. But if a building collapses, to restore that particular building, it's going to take some time. So you'll see that that whole time, people could have psychological problems as such. Because pipelines are going to be cut off, you'll see that there could be a secondary impact in the sense shortage of clean, or I would rather say potable drinking water. And of course, sanitation also is going to be a problem. Because you don't have potable drinking water, because you have sanitation problems, you'll have further secondary impacts, diseases. Okay, so you have to be very clear as to when you notice a particular impact, you should be able to identify whether this is a primary impact or whether this is a secondary impact. Roads blocked, destroyed, and because of this road blockages and destruction of airports, etc., this could lead to difficulty in aid and emergency vehicles reaching that particular site as such. So this is another serious issue as such, and that is why you'll see that whenever you have such occurrences, helicopters which can land straight and of course take off straight as well, you'll see that helicopters are put to use, because other aircrafts will take time to come down, and of course they require a runway, etc. So such aircrafts are not of use, though they may be larger in size. As okay, so secondary impacts further, you'll see that businesses get damaged and destroyed, which will lead to unemployment. A similar thing which happened with regards corona also. You see that corona is basically a biological thing. The first impact is biological. Okay, you get ill, you get sick, but over a period of time, the secondary impact is because of the breakdown, businesses go down, and unemployment may crop up, and so on and so forth. So these are the impacts of the earthquake. Now remember, these are general impacts. These are general impacts. If you see all these words that you can see in front of you, the bridges, the buildings, roads, railways, electricity, gas, telephone, all these broken underground sewage pipes, and so on and so forth, psychological problems, homeless people, these are human impacts, I would say. These are included initially basically because these are directly impacting human beings. But let me tell you that there are going to be impacts as far as the geomorphic impacts, as they are called, as such. Okay, so these impacts are human impacts, I would say, and then we need to go into the geomorphic impacts as such. For us, the geomorphic impacts are more important rather than the human impacts. Of course, human impacts are equally important, because finally we learn all these so that we would be in a position to know what could be the human impact. Okay, so just knowing about an earthquake is not enough. Okay, we need to know what goes beyond the information of an earthquake. How is it going to impact nature? How does it impact human beings? What parts of this human societies is it going to impact more? Who among the human societies will be impacted more? And that is what is more relevant, because other things you may be in a position to understand how an earthquake will happen and what is an earthquake prone zone. But if you don't know what impact it is going to create, the primary impact that it is going to create, the secondary impact it is going to create, and let us say you are in fact in charge of an NGO, you would not be able to provide aid in the right sense. Okay, just as I said, that you are very emotional, and you want to send maximum amount of aid, and you hire a charter plane, and you load a lot of help or aid into that particular plane. Eventually you find out that that plane is not going to take off, basically because the airports have been damaged there, and it would be very difficult, or it would be impossible to be landing your plane there. On the other hand, hiring a helicopter would be an easy thing to do, though the amount of aid that could be transferred would be less, but eventually you'll see that the amount of say the aid in itself is sure to reach a particular area. So you have to be very careful about this, and you will be careful only when you go into the analysis of all these things. Okay, the human impacts of the earthquake, the natural impacts of the earthquake, within human impacts, primary and secondary impacts, within natural impacts, the primary and secondary impacts as such. Okay, and because the first semester involves physical geography, we should be concentrating more on the physical impacts of an earthquake. Not that human impacts are not important. Let me tell you, and I repeat, that it is only because of these human impacts that we are learning all these things. Otherwise, there is no reason. Okay, as far as earthquakes are concerned, as far as volcanoes are concerned, you will be studying. You will not be studying them for the pleasure of learning. Okay, you'll see that there needs to be an output also of this learning as such. Okay, you may be learning a mountain or a river system for the pleasure of learning. But yes, there is a pleasure of learning in earthquakes and volcanoes also. But the final goal is protection of life and property, and this will happen only when you go know all the detailed impacts of these. As far as the human aspect of all these is concerned, we are going to take it up in the second semester. As far as the first semester is concerned, we need to go into the details of how all these things are going to happen. Let us go step by step. Okay, let us start from this particular point, that there is a main earthquake, okay, a focus. What will happen? Okay, from the focus, this will move up to the epicenter, and it is from the epicenter that it starts distributing. You would have the primary waves being deported, or say start moving. You have the secondary waves and you have the ground waves once it comes to the epicenter. Okay, let us say because of the ground waves, what would happen is the surface will rupture. Okay, the surface will rupture, and then of course, as I said, that the rate and the speed of each of these is different. So the primary waves will arrive first, and then you are going to have aftershocks. And in fact, if the ground waves have that energy, the latter aftershocks are going to be much more I would say what disastrous as such. Okay, this is going to happen on one side, and on the other side, this may lead to liquefaction also. Now, what exactly does this word liquefaction mean? Okay, lique means, of course, comes from the word liquid. Okay, when you put something in a liquefied mode, that is going to be called as a liquefaction. And you'll see that higher the intensity of an earthquake, larger is the possibility that a particular thing gets liquefied. Okay, you'll see that in many cases it so happens that things are ready, but they need that particular final force to start with. So you'll see that as far as landslide, for example, is concerned, a landslide could be an impact of liquefaction also. Okay, so in fact, we could have another arrow from here, that because of liquefaction, it would lead to landslides as well. Now let us see further what is going to happen as far as this earthquake is concerned. Okay, you'll see that when the landslide is happening, okay, now if this landslide slides into a lake, if this landslide slides into a sea, what I was referring to in the earlier slide as such, this landslide is going to block the flow of the water, one, or it is going to displace a significant amount of water. This displacement of water, particularly when it is in the coastal area and when the landslide is large enough, it could lead to for a tsunami. So you'll see that earthquake itself is causing a tsunami. Add to that, landslides also may cause a tsunami. A small landslide, let me tell you, will not have that much of an impact. But remember that if we link this, and I always am tempted to link this to human geography as such, okay, possibly a tsunami, a landslide generated tsunami would not have that much of an impact with regards a landslide happening into a lake, because you see that normally you have human settlements on the banks of the lakes. Now once you have these human settlements along the banks of the lakes, and imagine a landslide happens in the lake as such, the water is going to spill out, and this spill out of water is going to enter into all those settlements which are lining the lake as such. So you could have an impact there. The force with which the water is thrown out of the lake will decide how much damage has been caused as far as the landslide happening into a lake is concerned as such. A positive thing is that a landslide may cause a landslide dam also. Let me tell you that it will obstruct the flow of the river, and behind that you could have a dam. But let me tell you that all landslide dams would not be that useful, because it's not going to last long. And what is going to happen out of that, we'll come to that. But yeah, going down again, landslide will cause glacial disturbances also. Now, what are glacial disturbances? You'll see that glaciers, which is basically a pack of ice on the surface. Now, once you have landslide and you have a glacier above, both of them would in fact cause a compounded impact also. As okay, landslides will further cause debris flow. Okay, it's pronounced as debris and not debris. Okay, so it will cause debris flow. Glacial disturbances will also cause debris flows as such. Okay, so uh, this is what is going to happen in the natural environment. Let me tell you, in the natural environment. Okay, now further, what happens now? We thought of a case wherein a landslide dam is created, and we thank God that because of this landslide now we have assured supply of water. But not always you should be in a hurry to thank God, basically because let me tell you that this is not a very strong structure. Landslide, it's all unconsolidated material which falls in a particular place, and for a moment it is going to stop that particular flow of water. Now, what should happen if this is not consolidated? And see, if it had been so simple, constructing dams would have been so simple. Man would have done the same thing, isn't it? He would have dumped a lot of mud in the course of a river, and we could have had fantastic dams. But we don't do that. We have concrete, RCC. Most of the dams are RCC. Yes, there are a few mud dams, etc. Like I think the Hirakud in Orissa is a mud dam. But you'll see that in majority of the dams, you require RCC columns, and of course you build a wall and so on and so forth. That's basically because you don't want to risk what is called as a dam break flood. Okay, because at some point of time, this unconsolidated material, which comes down in the form of a landslide, may break open, and because of that, the water which has been stored behind that particular say landslide will suddenly gush out, and once water starts gushing up in the natural course, of course it will meander and it will move slowly. But just imagine that 10 times and 20 times that of water suddenly is released from a particular location. You'll see that in that case, what the amount of force that water has, it is not bound by the boundary of the channel as such. In fact, you'll see that it may bounce outside the channel, and it may enter settlements, it may enter fields, it may enter airports, wherever. Okay, it may enter, and it will cause a lot of destruction. Now, this dam break, just like debris flow, will come down here, and it will aggrade. Okay, aggrade in the sense it will heap up, it will pile up. Aggradation is a grade. Gradation is increase. Okay, so uh, glacial disturbances, debris flow, dam break, okay, all this is going to push all that material in a particular area, and that in that area that material will rise up, and that will lead to a gradation as such. And then another common thing that may happen out of what lake or a tsunami, a landslide dam, a dam break as such, and what do we have here? Glacial disturbances and aggradation. All of this will cause a lot of flooding. So you will see that in here, you hardly see a human being. In this whole complex web that we hardly see a human being. Everything is happening naturally in absence of human beings. So this is the geomorphological impact of the lands of an earthquake, sorry. And this is the human impact of an earthquake, okay, how it disturbs human systems, how an earthquake here disturbs um, natural systems as such. Now let me tell you that looking at this diagram, it would it would sense to be a very difficult thing and an unfortunate thing happening as far as human beings are concerned. But let me tell you that as in the natural environment, most of these things are necessary. And in the long run, let me tell you, most of the things in this thing are going to help human beings as well. Okay, like say for example, this last thing here, flooding. Yes, if floods are going to enter human settlements, then it is going to be difficult. One. Secondly, if floods are going to enter into agricultural fields, and it's going to and if that field has been just sowed with, or it has a standing crop as such, then it is going to be a human loss. But remember that what comes along with the flood is a lot of silt. Silting is very necessary as far as increase in the fertility of the soil is concerned. Okay, unless and until you have silt, in fact, you'll see that as far as the river Nile is concerned, the deltas of the Nile is concerned. If you go to the history of the Egyptians, you'll see that they had mastered the art of identifying when the Nile would flood, and during that time they would stay away from it, and while the Nile was on its full flow, they would not go near the Nile River. But when it got down ebb, they would just clear off the say the larger debris, and then they would start plowing it. And that is one of the main reasons why the Egyptian civilization extended into a few thousand years before Christ also. Okay, the regularity as far as the silting is concerned. By the way, I don't know how many of you all know this, but uh, if you ask me where this silt comes from, because just silt coming is also not so to say beneficial as far as agriculture is concerned. That silt should have those minerals which will help vegetation to crop up and be healthy at the same time. Also remember that a very large flood and a very sudden flood is going to get in a lot of debris which is going to be unconsolidated and which is going to be ungraded. Okay, ungraded in the sense you'll have material size from a very small size to a very large size, and after the flood ebbs, you'll see that all of it is spewed into the field as such. So such types of floods, I would say, is not are not that beneficial. But areas wherein you have regular flooding, I'm not speaking about flash flooding, but you have seasonal flooding, that you have rains, and because of rain, the amount of water in the channel is going to increase, and it's gradually going to increase, and it's going to gradually subside as well. Because of this, what happens is that the silt particles, okay, the silt particles that silt down on the river plains are going to be more or less of the same size, and once the air flood recedes, you're going to have a lot of clay material which is on the surface. Now this clay material has a lot of minerals in it which enrich the quality of the soil. Now, taking you to the Nile once again, when we speak about what enriched the Nile Delta, once we finish the lecture, you can go back to the tracking the river Nile on Google as such, and you'll see that while the main Nile starts near the Livingston waterfalls, central part of Africa, and then it moves all the way upwards. That's upwards in the sense towards the north, and it opens into the Mediterranean Sea. you will have to look for a river which joins it from the eastern side, just a bit south of uh, the country of Egypt. I think it happened somewhere in Sudan, as such. Now, this river, I forget the name of this river, it comes from the Ethiopian highlands. Now, what makes the Ethiopian highlands and the river coming from the Ethiopian highlands more important or so important for the Nile River? Now, the Ethiopian highlands are recent volcanic features. It's a recent volcanic feature. Now, when you have a river coming in from that area, of course, it is going to erode a lot of minerals from this area. So all the richness, as far as the silt is concerned, for the Nile is concerned, it does not come from the origin of the Nile, but it comes from these Ethiopian highlands. Okay, it is believed that if the Ethiopian highlands would not have been there, probably the Egyptians would not have survived for such long a period, because this would eventually, what would have happened is the fertility of the soil along the banks or the river banks of the floodplains of the Nile, so-called floodplains of the Nile, would have gone down, and because of that, the production would have gone down. One of the main reasons why the civilizations of Mohenjo-daro and Harappa are supposed to have subsided. Many believe that it's basically because of the shifting of the river Indus. One, then we know that about the mythological river Saraswati, which may have gone extinct because of various geological reasons, but it led to the total extinction or abandonment, sorry, of the cities of Mohenjo-daro, Harappa, and of course you have many new sites which are coming up in that particular state. So all this has to be put up in larger perspective, looking at a particular point, and that is why I keep on saying that scale is very important as far as study of geography is concerned. You should be in a position to zoom in, to have a very micro view of a particular thing happening, and within seconds you should be able to zoom out, so that you should be able to understand what actually is this thing related to. Now, just imagine that if I had said that, okay, we are speaking only about this, we could have had various explanations to flooding, but now we know that this flooding is related, and of course it has backward connections to many things. So to avoid flooding, we could think of, say, avoiding aggradation. One, avoiding glacial disturbances. Two, avoiding landslide dams. Three, avoiding surface rupture. Four, okay, avoiding landslides. Five, avoid checking, or rather having an idea about which areas are prone to earthquakes and how regularly and what magnitude earthquakes are going to happen in this particular area. So you go on back tracing, and you should be able to identify what would be the basic causes for it. This is very important, and this is the most advantageous things of scale in geography. Okay, you can zoom into the micro level, and of course you can zoom out into what is called as the macro level also. Okay, so this is the natural impact, and remember that an earthquake, in fact, is called as an so to say a constructive force for us. Howsoever, I did speak about this earlier also. For us, howsoever destructive an earthquake may be, for human beings, that is, howsoever destructive the earthquake may be, howsoever destructive a volcano may be, both of these features, let me tell you, both of these features are considered as constructive forces. They are endogenetic, and they are considered to be constructive because they are known to construct the crust. Okay, they of course, volcano, it's so very simple that it's going to spew up magma, and this lava that comes out going to solidify, and you're going to have new crust. At the same time, as far as tensions within the crust are concerned, they tend to be released out of these earthquakes happening around us. So either ways, both of them, the landslides and volcanoes, are constructive. Howsoever we may call them destructive, keeping in mind the human aspect only as such. So this is another important learning point that we have to take from here, that we should be able to zoom out into an issue, a problem, and at the same time you should be zoom in, and of course you should be able to zoom out also, so that you should be in a position to know how well it is connected to other things. Okay. uh, in simple words, going to the root cause is possible when you zoom out of that particular event, and you think about how this is linked to and what this is linked to, and so on and so forth. Another picture explaining the impact as far as the earthquakes are concerned as such. Okay, you'll see that towards the center, I'll just enlarge it so that we, okay, you'll see that towards the center we have an earthquake. Okay, an earthquake will lead to a landslide. It will lead to a rock slide or rock fall also. Of course, this is dependent on the material. If it is muddy, then you call it as a slide. If it is rocky, you call it as a fall, because of course it's going to move faster. Okay, if it's going to be very very fine, then you'll see it's going to be called as debris flow. Okay, and then it will lead to slope weakening and so on and so forth. So this is an original earthquake will lead to these things happening. Then into this section now, what will happen? Okay, you'll see that because of this, at the same time you have rainfall, and because of the rainfall you have post seismic debris flow. Okay, so this is again another way of looking into the secondary impacts as such. This debris flow now becomes a source material for a dam slide, or rather a landslide dam. Okay, so you'll see that this has slided down from this particular area here, and this is going to block. Okay, the lake, or rather the river was flowing like this. The river was flowing like this, and suddenly it gets transferred into a lake. Of course, it will not stay a lake for a long period unless and until, of course, this mudslide is so huge that it takes some time, and the lake it does not have a very regular source of water. The source of water for this particular lake, let us say, is only snow. Okay, now because it is snow, it could limit itself to being a lake. Initially, this meltwater of the snow was flowing for a longer period, but now what is happening is because of this sudden debris flow, it has blocked, and what was flowing as a very narrow river has now grown into a lake. Now, as I said, that in some course of time, in some period of time, the amount of water that has been accumulating behind that debris flow will increase and increase and increase, and it will gather. One day, it will gather that much amount of force to breach through that dump. Because, as I said, it is not a concrete wall; it is just accumulation of material, and one fine day it will break, and suddenly the water will gush out, and you would have a dam break flood as such. And what happens because of that? You'll see that this will lead to a downstream flood. Okay, and it will enter, as I said, that this time, because of the force of the water is so huge, it is not necessary that the river will keep track of its course. Okay, it will just break anything that comes in its way, and it will enter into cities and towns and villages in its course. Okay, so that will lead to downstream flood as well. Okay, then you'll see that another thing that could happen here is because of the tectonic movement. Because of the tectonic movement, there could be sediment transport, at the same time sediment deposition because of the rainfall, and because of the tectonic movement, there is an upliftment as far as the river bed is concerned. Sediment transport channel leads to a gradation, and the river bed tends to rise as. Okay, post seismic landslides, you'll see that afterwards, because of the aftershocks, you could have post seismic landslides also. And you'll see that this mass failures, which is a very common legacy as far as the earthquakes are concerned, weathering creeping along with mass failure will lead to these sediment materials, which may cause all these problems that we are seeing in front of us. So this is as far as the impact of the earthquakes are concerned. Okay, we have tried to combine. Okay, what we did earlier was we took a human slide and we took a natural slide. Now, of course, the world does not operate in that particular way. It operates together. It's an integrated world. So when you put it in an integrated way, okay, you'll see that this should be happening. Okay, then on if you see this bottom of the, I just enlarge it for you all. If you see here, you'll see earthquakes time scale. What should happen in years, what should happen in decades, and what should happen in centuries. That is how you need to uh, uh, read into this particular diagram. Everything that we have explained earlier, and which of these is going to happen immediately, which is going to happen take some time, and of course, which could take much more time as such. Okay, so this is as far as earthquakes are concerned. I'm going to stop sharing here, and let us see if you have any questions for the day for me. And if the questions are answerable right away, I would be answering your questions. But if I find it difficult, I'll come back with your answers next time. As I said, probably 99% next time we should be shifting on to the Google platform. And your regular complaint that as far as the uh, slides are concerned, they are not legible, or rather they are not readable on a mobile phone. I think we should be in a position to do away with those difficulties when we meet next time as such. Okay, so if you have any questions, you can still post it. I'm there for a couple of more minutes as such. If you don't have questions, then we could call it a day, and I would end this broadcast here. Yeah, if you have any questions, you can ask me your questions. If you don't have questions, then yes, we'll stop here today. We'll meet tomorrow once again, and we'll start with a fresh topic next time. Uh, Thank you very much, and I'm ending my broadcast right here. Yeah. I have a. Sorry, I'm not ending it. I have two questions. Sir, could you send today's slide? Now, which slide do you want? I'm not very sure. If you could just be particular about which slide you want, I could do that with your. And sir, what is a shadow zone is a question. The earlier question was, sir, could you send us today's slide? My response to that is, what slide exactly do you want? And the second one is, sir, what is a shadow zone? As I said earlier also, that shadow is something which is in protection. So any zone on the surface which is um, uh, which is not impacted by the earthquake waves, okay, particularly the primary waves as such, okay, because secondary waves do not reach the other side of the of the surface of the earth, okay, but primary waves do reach, and such areas wherein they don't reach. Now, why don't they reach? We have done this in this very lecture, that because of the reflection and refraction, some areas are left unattended, and such unattended areas, they have been geometrically worked out from around 93 degrees from the point at which the epicenter of a particular. Okay, shadow zones will change. Let me tell you, I did say this earlier also. They're very dynamic. They will change with every earthquake. Okay, so from 93 degrees from the epicenter to 143 degrees is going to be that area which will not have the adverse impacts or whatever impacts as far as a particular earthquake is concerned. So that is as far as shadow zone of an earthquake is concerned. And she says impacts of earthquakes. Okay, I'll do that. I'll try to put up the PPT of this very presentation on the group so that you could just go through them as such. If I forget, please remember that you remind me about this. I have to put in the PPT of the earlier one also. I'll just check if all things are in right, say, and by today evening I should be posting you the PowerPoint presentations of whatever we have done to date as such. Okay, so we'll stop here for today, and we're meeting tomorrow. Okay, thank you very much. I end my broadcast here.